All right, problem number 5. We have William, and he's at the Lucky 7 Duck Pond game. And at this game, we've got 10 rubber duckies that are uniquely numbered 1 through 10 on the bottom. And he chooses one duck, and then without replacing the first, he chooses a second. And we're asked, what is the probability that the numbers on the bottoms of the two ducks add to exactly 7? Okay? So, let me see. Probability. Let me give you your hint, I guess, will be that to remember what probability means. So, probability is just, it's the number of desired outcomes, and in this case, our desired outcome is 7 over the number of total outcomes. So the denominator would be all, the number of total possibilities that you could, of ways that you could choose the ducks. Okay? So we need to figure out how many ways can you make 7 from the numbers on the bottoms of two ducks, and divide that by the total number of ways that you could get two ducks. So, your ducks could have 3 and 4, which would add to 7, or they could have 1 and 2, which wouldn't give you 7, but it is a possibility. So obviously this is going to be a bigger number because there's a lot of ways you could choose the two ducks, but only a few that are going to give you 7. Okay? So one thing you might try is to, I'm going to scroll down here and see if this works, is to draw a table. See if I can paste this in here. Aha, there it worked. Where you look at all the possibilities. Ooh, that's kind of long. So, so if you're choosing two, ducks, the first duck is going to be numbered 1 through 10, and the second duck could be numbered 1 through 10, but they can't be the same number because you didn't, whoops, I guess I have to do that. Okay. So you can't get 1 and 1, you can't get 2 and 2, you can't get 3 and 3, 4 and 4, 5 and 5, and so on down the diagonal. You can't get those. So this might help you see, by drawing this table, it might help you see what you're working with. Okay? So essentially you got 10 by 10, a 10 by 10 grid, but some of these aren't possible. Alright, so let's go ahead and solve this problem. Scroll back up slightly here. And, okay, so we want to find out what's the total number of desired outcomes. So how many ways can we make 7? And just if you have this table, you can actually see that 1 and 6 would make 7, 5 and 2, 4 and 3, 3 and 4, 2 and 5, or 6 and 1, right? So you can see we have 6 ways to make 7. So in our probability, 6 is going to be the numerator. Okay? And then in the denominator, we've got this 10 by 10 grid, but some of these are not possible because he's not replacing the ducks. So if you chose a 4 on your first duck, you can't choose 4 again because the 4 has been taken out of the pool. So so there's some of them that aren't possible. So if you take this 10 by 10, which would be 100 possibilities, and take out the ones that aren't possible, which are the 1 and 1, 2 and 2, there's 10 of these that aren't possible. So you actually have 90 total possibilities for the two ducks. Okay? And that's your probability. You got 6 ways to make 7 and 90 possible ways to choose the ducks. And if you reduce that down, you get 1 over 15. All right? And that's the answer. Now, there's a number of different ways that you can do this. One way is, I would say another way you could do it is, again, you can list out the number of ways to make 7, which would be 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. So you got 6 possible ways to make 7, and the total possible ways, you could use a permutation, and you could say, well, I've got 10 choices for the first duck, and then if I don't replace the first duck, then I only have 9 choices for the second duck, which is going to be 90. And then you get 6 over 90 again for your probability. Okay? Now you might be thinking to yourself, or if you were here you'd be telling me, but hey, wait a minute, when you add numbers the order doesn't matter, so why are you using a permutation? And I would say that's a very good point. Let's try it using combinations instead. So using combinations, now in combinations the order doesn't matter, so really we'd have half the possibilities or half the number of ways to make 7. 1 and 6, 2 and 5, 3 and 4, because 4 and 3 is the same as 3 and 4, and 5 and 2 is the same as 2 and 5. And so really we'd only have 3 ways to make 7, and if we take 10, choose 2, that would be 10 times 9 over 2, which is 45. Okay, so again we have half the number of ways, half the number of total possibilities. So our probability here would be 3 over 45, which is still equal to 1 over 15. Okay? And the key here is that if you choose permutations to do your probability, you have to make sure that your numerator and your denominator are done using permutations. Okay, so be consistent. If you're using combinations, you have to make sure that the numerator and the denominator are both combinations. Okay, so if order doesn't matter, you have to make sure that both the numerator and the denominator assume that order doesn't matter. And if you're assuming that order does matter, you have to make sure that your numerator and your denominator assume that order doesn't matter, or order does matter if you're using permutations. Okay, so just be consistent. If you're using either use a permutation over a permutation or use a combination over a combination, but be consistent. All right, so there's your answer, 1/15.